this video is about Newton's method. This is not really in our syllabus. This is just an additional info just for fun. So we have this function y equals f of x, and we want to find the root, the solution to the y equals 0, the x-intercept. If we want to find this root, we can use this kind of method. So we guess. So the root is around x naught, for example. So this x naught is our first guess, our first estimation. And if the x value is x naught, of course the y value is f of x naught. So just plug in the x naught here and you get the y value. So the y value is f of x naught. And if at this point you draw the tangent line, we have this blue line. So this blue line is actually the tangent line when the x value is x naught. To find the gradient of this blue tangent line, we can use f prime of x naught. So we differentiate the function and we plug in x naught. And if we want to find the equation to this tangent line, well, we have the gradient and we have the point. We can use the y minus y1 formula. Y minus y1 equals mx minus x1. Plug in the x1, y1 and the m, we get the equation. And from this equation, we can find the x-intercept. So the x-intercept of this blue straight line is when the y equals 0. So you plug in this y here, replace this y with 0. We have 0 equals the y1, the gradient, and the x minus x1. You also plug in x equals x1 here. So this x1 is the x-intercept, and this is like a better approximation of the root. So we started with this x naught, and now we get a better approximation. This is closer to the real root. And if you rearrange here, we get the x1 equals something in terms of x naught. So x naught minus f of x naught divided by f prime of x naught. So if we repeat the process from this x1, we can like trace this the value of x1 on the green curve here. So around here we have this point, and we can find the y value, which is f of x1, and we can draw the tangent line again. So we can repeat exactly the same process but with the point x1. So x1 comma f of x1, and the gradient is f prime of x1, and we can repeat the process again and so on. So that's called the Newton's method. We are trying to find the root by drawing tangent lines. So for example, find an approximate value for the cube root of 2. Well, you can find the function first. So let's say the cube root of 2 is x, which means x cubed equals 2, and if we just subtract 2 from both sides, we get x cubed minus 2 equals 0. So we have this function and something equals 0, so we are finding the x-intercept of this function. So the function is x cubed minus 2, and the f prime is 3x squared. We differentiate, and the x1 formula, so the next x value is the previous x value minus f of x naught divided by f prime of x naught. So let's say our first guess is 1, let's say. So we plug in x naught equals 1, 1, 1. So using a calculator, you'll get some value, and just press the back button in your calculator, replace the 1 with the answer button. So delete this one and press the answer button, delete the 1, press the answer button, 1 answer button, you'll get this in your calculator. Hit equal sign and you'll get the next approximation, and if you hit the equal sign again, you get the next equal approximation, and you can just keep pressing the equal sign until the displayed number in your calculator doesn't change anymore. So that'll be the best approximation your calculator can find. So it's correct to 1 2 3 4 5 6 7 8 9 10 significant figures, and you can compare it with the usual calculator value of cube root of 2 actually, and you'll see that they are exactly the same. Alright, that's Newton's method. I'll see you again next time.